All right, ladies and gentlemen, here's what we're going to do. We're going to learn how to build this circuit on the computer using breadboards and switches, but doing it all on the computer using a program called TinkerCAD. So what I want you to do is go to your internet and go to tinkercad.com, and you should already have an account with your student Gmail account. So you should be able to log in with Google. Once you're logged in, you should get something that looks about like this. And I want you to select underneath your name circuits. And inside circuits, you can select create a new circuit. It'll take a second. And what we're going to do inside here is we're actually going to build the circuit that you saw on page 58 in your packet. So we've got a 9-volt power source, a 330 ohm resistor. This is a switch. This is a diode. This is a voltmeter, so something to measure the voltage, all right? And the diode, we're actually going to use a light emitting diode like this. So it only allows electrons to pass through it in one direction. So you'll notice here it says the short wire is the cathode or the negative leg. So that needs to be attached to the negative side of the power, right? See how the negative's right here wrapping around. So they gave me a nice little schematic here to show me how it's all wired together, and you can see it even better right here. But I'm going to make it so you can see it even better than that. Ready, ladies and gentlemen? Here we go. First thing is, we need to have a breadboard. So all I'm doing is I'm using the little wheel on my mouse, and I'm scrolling down. I'm going to click on the breadboard small, and oops, I'm starting to create wires. And I'm going to put that in right there. I need to have a battery source. So I'm going to select a 9-volt battery, and I'm going to connect it. It's already 9 volts. The negative to the negative. And then if I click on that or it pops up, I can make that black just like it is, which is cool. And then I can click on this one and bring it to here, to my positive, and make it red, just like the positive. So what that means on this breadboard is that all of these, you see how they all light up green? They're all connected together with the negative side of the battery. And these ones here are all connected with the positive side of the battery, or the red. All right. Next thing, if I go back and look at my screen, I can see that's how I've connected my battery. And it looks like right here I've got a resistor that jumps over to a switch. And it is if you look down here, it's a 330 ohm resistor. So let's go back to that and let's find a resistor. Boom. So we'll drop that in here about like so. All right. So you'll notice I actually connected it to the negative side, and I connected it to this row right here, or column, I guess, the way I have this oriented. I'm going to change the resistance to 330, not kilo ohms, but ohms, right? So 330 ohms. And you'll notice that the color bands changed because the colors of the resistor are different. I'm going to drag a switch in, and I want that switch to communicate with the, or to be, I guess, in line with the resistor. So you notice all of these holes turn green together. So that means that my negative side comes in here, connects to the resistor here. The resistor then connects it across here, to the switch. And the switch actually goes and jumps from there over to here when you press it, right? Only when you press it, though. So next thing I need is a diode, LED, all right? And the short leg is the negative side. So I'm actually going to put it here to start. And what color do you want it to be? I like green because, cash money. So we'll go ahead and rotate it around about like so. And what I'm going to do is I'm going to connect it to the switch. So you see how these are all lighting up green? That means that this part of the switch is connected to that part. I don't want to have the other side, the cathode side, connected. Oops, I might have this backwards actually, because that's saying cathode, so that's the short side. So let me go ahead and switch that around. Toot, 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 toot. And I'll put that in there. And then I'm going to just go ahead and jump from here across to my positive side. And we'll just leave that as a green switch, green wire. That's perfect. Now, I've wired it up. I can click Start Simulation. And when I press this button, you'll notice I get light. Let there be light. Isn't that beautiful? All right, you can clap now. Okay, stop. That's enough. Now, if you're looking on page 58, you'll notice that on page 58, I also have a voltmeter, which isn't in this picture here. So I need to see what the voltage of that is. And it's telling me what is the voltage from the power supply. Well, we know that's 9 volts. How much voltage is across the resistor and the diode. But be careful. It says that you're going to use the switch open, right? And an open switch means it's not pressed. So will I have any voltage across the diode? The answer is no, because there's no way for those electrons to get past an open switch. Will I have voltage across the resistor? No, because there's no way for those electrons to get back past the switch. So 9 volts for the power supply, 0 for the rest. Let me just show you, because that is with the switch not pressed. So let's go ahead and grab a voltmeter. Does anybody see a voltmeter? Oh, there's a multimeter. And what I'm going to do is I'm going to zoom out. And you'll notice it has V pressed. So that's V for voltage. This is the negative side. So I'm going to go ahead and measure the voltage across the resistor to start. So what I do is I touch both of the metal sides of that resistor. And you'll notice that when I start my simulation, it says 0 volts. If I press the button, I actually have a voltage there, right? But right now it's 0. Let's go ahead and add in another multimeter, and we'll check the voltage of the diode, the LED. So the positive side should be here. And oops, I missed it. And oops, I missed it again. There, and we'll make that one red. And then we should also have the negative side. We'll make that black. And we'll start our simulation. It has a little bit of voltage, but not really any voltage. That just happens to be what it's measuring. I press it, and boom. Ladies and gentlemen, I hope you notice that when you add 6.88 volts plus 2.08 volts, you're very close, but not right at 9 volts. So you can record those values in your packet and then flip the page and record the values for the closed switch. All right. And if we have time, I'm going to go ahead and show you how to do the current, which means I'm going to break the switch. So coming back to my circuit, I'm going to put stop the simulation, another multimeter in, but this time I'm going to change it from voltage to amperage. And I'm going to remove this wire on my LED, and I'm going to have my multimeter do that connection. And when I click Start Simulation, there is no amperage. When I press the button, I get 20.9 milliamps. Beautiful. Thank you for watching. As always, ring that bell, punch that like button, and holler at your boy in the comments below. Report him.